Okay. Okay, so let's write this question. This is about relative speed. So let's see. So two trains, X and Y, are positioned as shown at t equals to 0. So there is one train X that is going at 30 meters per second. There is another train Y which is going at 20 meters per second, and the distance between them is 50 meters. Right now, so it says what time t the train X is level with Y. So what you guys should understand is, in these sort of questions, that you got to find the difference of speed. So that would be 30 minus 20. So the difference between them is that X is 10 meters per second faster, although it's going at 30, but relatively, according to Y, it is just 10 meters per second faster. And at time 0, the difference of distance between them has to be only 50 meters because that's the length, right? So then what you do, you use the time taken will be basically the distance over speed, and that could be 50 divided by 10. So it would take 5 seconds for X to be level with Y. Is it clear, everyone?
Yes, sir.
So please do remember that relatively that's the difference. Now that's just a small thing that I wanted to put forward. So now today we are going to do experiment to determine acceleration due to gravity. Okay, for this one, just a second, let me just copy a diagram that we got to use. Okay, it will be here soon. Okay, so in this one, hold on a second please. Hello, Caroline को ऐड कर लेना अपने पास में. Okay, see, अभी मैं पढ़ा रहा बाद. Okay, so there is a small metal sphere which is basically connected to an electromagnet. By now you should know what is an electromagnet. In O levels you have done that it is basically a magnet. When you turn it on, it becomes magnetic, so it touches the metal sphere. And here the green and here this is a trap door connected to a data logger. So what it does is that when the object falls, so this is the height h it falls. Okay, now, so when this object falls, it will take a certain amount of time to hit the trapdoor, and then it can, as the trapdoor opens, basically it will calculate the time between the release of the magnet till it opens the trapdoor, so automatically it will be calculated, right? So what you're going to do is you're going to make a table. So a table is drawn by taking time of free fall with multiple values of h. So we keep on changing the height, and then we take about 6 readings. Okay, so the table looks like this. So you gotta have h in meters, and then of course we just take, just for our own self, we repeat the experiment, take time for it, and then we take average of time, and I'm writing the units beside it, and then we take square of the time like this. Okay, so it would be second square. Is it clear, everybody?
Yes, sir.
So when I'm done with this, what you want to do is you want to draw a graph of best fit between h and t square. Now, then h on y-axis, t square on the x-axis, and then basically when you plot the points, you just need to draw a line of best fit that starts from origin. Now I just want to tell you, the line of best fit is a line that basically whether it touches any point or not, it should be like dividing points equally on top and below it, right? So like above and below there are like 3 and 3 points. So now if you look at it, this whole thing, why do I know that this will be like this? Because according to free fall, the displacement will be h, the initial velocity will be 0 because the final velocity will not be known. A is the acceleration due to gravity, we'll call it g, that we are finding, and time will be t for it to fall. So the best equation to use would be s equals to ut plus half at square, and if I put in the points, right, so it will be h equals to 0 because u was 0 plus half g t square. Now, so ultimately we are going to get half g t square. Is it clear? If you notice this line, you can then compare it with y equals to mx, which is an equation of straight line starting from origin in mathematics. And from this point onwards, you can see the h is on the y-axis, just like here. T square is on the x-axis, which means that the gradient of this line would be equal to half times g. Now, since we want to find g, we would say that g will then be equal to 2 times the gradient of this line. Is it clear, everybody?
Yes.
Okay, please write this down then. It's very important because they might ask you to do it.
So gradient is 2 times height.
2 times, sorry? Gradient is 2
2 times height.
No, 2 times. G is 2 times the gradient.
Okay.
Because I compared it with y is equal to mx. You see, on y-axis I have h, on x-axis we have t square. So m is the gradient in this equation, which means gradient will be equal to half g. Do you see? Right here. Okay. All right, should I go forward then?
Yes, sir, I finished copying.
Okay, very good. Now, so this basically marks the beginning of vertical motion of an object. So what you should do is, you should understand that if there is an object that falls down, right, like this, so whatever its initial velocity is, the final will be larger than that. So if it's going at 0, it will have some final velocity v. The reason is that when it falls a significant distance like h or s, the acceleration due to gravity is always acting downwards. Is it clear?
Yes, sir.
Now, so remember, and this is very important to understand, that if the direction of velocity and g are same, we take g to be plus 9.81 meters per second square. Is it clear? The other way is that if something is thrown up, so let's suppose initial velocity is u, and when something is thrown upwards, reaches some height, so at maximum height, it will have no velocity at all. So this is basically maximum displacement. The reason is that no matter whether it's going up or down, the g will always be down. Is it clear?
Yes, sir.
So you guys need to understand that if the direction of velocity and g are opposite, that could only be possible it's going up, then we take g to be minus 9.81 because this is a vector quantity, right? So that's why we need to put a sign that it is in the opposite direction. Is it clear?
Yes, sir.
And at maximum height, velocity v is always 0. Just need to remember that. Okay, please write this down. Okay, so just to reinforce this, or no, I just need to show you one question. So says fill in the, sorry, I'll do it differently. Taking up direction up as negative, choose the best values for acceleration due to gravity. So they have given you a couple of things like what is happening at rest, going up, going down, and at max height. So, and some options are given. And so usually these questions will be in the same MCQs. As I'm writing, you should be thinking about the answer, please. Okay. What do you guys say?
Sir, A.
A. Okay.
A.
A. Okay. Who else says A?
Yeah, sir. J.
So basically, according to you, you're saying that currently, if you're at rest, you're like sitting on a chair or maybe lying on a bed, you do not feel acceleration due to gravity. Is that correct?
Yes, sir.
Yes.
Why aren't you guys floating then? If you have a weight, you know the formula for weight, which is W equals to mg. If you have a weight, you gotta be feeling acceleration, don't you think so? So that means A is wrong. Acceleration due to gravity is always there, no matter what. Is it clear, everybody? The other thing you should thought about is that acceleration due to gravity, like I said from the previous diagram, I just gave you reference to G. G is always down. In the first section, I took positive down, so I took G as positive, and when I took positive up, I took G as negative. Do you guys understand what I'm saying? So it means that G will, if I have taken the direction up as negative, then actually the G at all points will be positive and it will always be down. That is the reason. Is it clear? If they had said taking direction up as positive, then I would choose C, that I've taken up as positive, so everything that is down is negative. So then it would be C. But because we took up as negative, everything down is positive. Is it clear, everybody?
Yes, sir.
And always remember, no matter what,
Yes, sir.
you will always feel, every object will feel acceleration due to gravity at rest, at sleeping, eating, whatever. Is it clear? So make sure that concept is clear. Now, this is the reason this question is very good. So, from this point, we can now understand the free fall. And free fall basically means falling without presence of air. So which means if air is not present or it's not significant, the resistance, so we can do it, right? Our meeting will end in 5 minutes, so you guys gotta rejoin, okay? Now, so suppose in the first section, when the object was at rest before it started falling, so initial velocity is 0, and we must understand the acceleration due to gravity G is 9.81 meters per second square. It will always be there. So this is the reason that this object will have some weight on it. Is it clear? Now let's make a table. So we want to have velocity in meters per second. We got to have time, we got to have acceleration, and we got to have G. So this is basically, just want to tell you, this is the net acceleration, okay, the overall acceleration that's happening. So when the time was 0, the speed was 0, acceleration was basically equal to G, 9.81, right? The moment it started falling, so the weight is still the same, and now the speed is going to increase to basically 9.81, and the g is still the same, and because that acceleration is also the same, so we can write now it's 9.81 in the first second, acceleration is the same, and g is the same. So now you might be wondering, why am I writing acceleration g differently, but I'll tell you why later on. In the next second, it will continue to fall. Now the speed will increase to 19.62, which means 9.8 plus 9.8, because acceleration adds it up. So it's 19.62 the second. The acceleration is the same as the g. Is it clear, everybody? It will continue to do so until the object hits the floor. Is it clear, everybody?
Yes, sir.
Yes.
Now this is free fall, right? Because it's falling in presence of, not falling in presence of air. What if now it is falling in presence of air? And now that's something very, very important. Okay, how much time we got? 2 minutes. Okay. So for that, initially we have this object which has a weight. Let me make weight a little bit bigger. So, and the initial velocity is 0, and you guys know g is 9.81. We're going to make the same table. Make speed in meters per second, time in seconds, acceleration, and g. So the speed was 0 when time was 0, because the motion has not started. Acceleration is the same as g. Now okay, we have 1 minute left, so I'm gonna just stop here. Let's chill for 1 minute, take a break, and then rejoin and restart. Okay. Okay, everybody's here. All right. Well, let's wait 1 minute. Okay. Now, check this out. So, the thing is that when it continues to fall, the weight is still there, but the speed increases to 9.81, just like the last time. The moment it increases, now the new velocity is like 9.81. The time was 1 second. The acceleration due to gravity is always the same, but the net acceleration changes. The reason behind this is that the air will cause a little bit of resistance against the velocity, because air resistance is always sort of a dynamic friction which causes an opposing force, which means now the acceleration might reduce to some value like, say, let's just take 8. Okay, now the new acceleration becomes 8. This means that when the next time, in the next second, when it falls, it's falling, right, the weight is still the same. Now the new velocity would be 9.81 plus 8, which is 17.81, and the air resistance will further increase, because as the speed will increase, air resistance will increase. So now you have 17.81 new velocity in the second, and now because there is even a bigger resistance force, which means the net acceleration will reduce. The acceleration due to gravity never changes, it's still the same, right? So in the next second, what happens is, when it's falling, the weight is there, and at one point, right, there will be a point when the air resistance and the weight are going to be equal. So the new velocity is 17.8 plus 4 would be actually something like, say, 21.81 meters per second. So the new velocity is 21.81 in the third second, and now because weight and acceleration, air resistance are equal, which means the net acceleration will be 0. Acceleration due to gravity is still the same. From this point onwards, the object will continue to fall at the same constant speed, and this speed is known as the terminal velocity. Is it clear, everybody? Can you please write it down? If you have a question, please let me know. Everybody understands this?
Yes, sir.
Okay, so if they ask you what exactly happened here, you can actually simply explain this by saying, number one, when an object falls in presence of air due to gravity, its weight is always acting downwards. Now, as the speed increases, so does the drag force, and drag force is basically the air resistance in this case, right? Now, at a point where air resistance and weight becomes equal, acceleration of the body is zero. Hence, the resultant force is also zero, right? The object reaches a constant velocity because there is no acceleration, right? Net acceleration, known as the terminal velocity. Okay. Written, guys? Any thing you wanna ask?
No, sir.
Okay, perfect. Now, because it is like decreasing acceleration, the last thing I want to tell you is the graph. And the graph for this would be, if you make, by the way, you already know this, this is the similar graph as the one you drew in O-levels. So it will be like decreasing acceleration and then constant velocity. So that would be the point where it reaches terminal velocity. So you can draw this too. All right.